Now that we've learned to solve rational equations, let's look at applications involving them. We're going to look at work rate problems, we're going to look at rational functions, as well as distance problems. Let's start with work rate problems. What a work rate problem is a situation where you know individual times for how long it would take someone to get a job done versus how long it would take them to get something done together. So here's a simple example. Working alone, Lola takes 3 hours to paint the side of a large building, and Deo takes 4 hours to paint the same wall, or the same side of the building. How long would it take them to paint the side of this building together? So we can kind of draw that out. I chose a building because it's easy to draw a rectangle and think of that as the side of the wall. So let's say this is the wall. Lola takes 3 hours to paint the whole wall. So if you imagine her starting from this side, it takes her 3 hours to paint it. She's going to get a third of the job done in the 1 hour. So in 1 hour, she gets like this much. She's a third of the way through the wall. Deo is going to take 4 hours. Let's say he's working from this side. If he's going to take 4 hours, that's like half of a half. So halfway through the wall would be there, so a quarter of the way through would be about this much in 1 hour. So he's working this direction. Now, if they keep going, in hour 2, Lola, by the end of hour 2, will be approximately here. She's going to be another third of the way through the wall. And Deo is going to be another fourth of the way through. So he's going to be halfway through the wall. So if you look at that, they end up overlapping at a certain point. So in hour 2, they end up overlapping or basically meeting each other. So they're basically going to complete this task sometime in hour 2. So in terms of how long it takes them, it's going to take them between 1 and 2 hours to paint this wall together. Well, how can we figure out how much time it takes them exactly to paint that wall together? Well, we have a formula for that. And it's a formula that we've looked at when we solve for formulas. 1 over a plus 1 over b equals 1 over t. Now, what do a, b, and t stand for? Well, a stands for the amount of time it takes one person to complete the task. B is the amount of time it takes another person to complete that same task. And t is the amount of time it takes them to work together. Basically, how this is derived is by thinking about how much can get done in a single hour. If you think about Lola as being one person getting the job done in 3 hours, what she can get done in an hour is 1 over 3. She can get a third of the job done in an hour. That would be equivalent to saying 1 over a if the time was a for one person getting a job done. Deo takes 4 hours, so in an hour he gets a fourth of the job done. When you add those two together, that will tell you how much they get done together in an hour. And if the whole job is happening, that would be 1/10 of the job. So this formula actually comes from looking at a single hour, basically the first hour of work. Now there is another way to write the formula, and I've written it down here. It's an alternative way to write out the same relationship. But what it does is it looks at the whole task. And you can solve and get the exact same answers using this way of writing the formula. In this way, what you're doing is you're thinking about Lola taking t hours to get 1/3 of the job done, and Deo taking t hours to get one, and he's doing 1/4 of the job in each hour. And you add up together that they're doing t hours of 1/3 and 1/4 work. That should get the entire task done. 1 standing for whole, 1 whole job. So it's another way of interpreting what's happening here. Either one will get you to the right answer. I'm going to use the first one, and it's often the one I find it's easier for me to remember this because the fractions are so similar in that form of writing the equation. But you're welcome to use either of the two formulas to get the same result. So I've already written it out that way. To solve this equation, we want to think about clearing fractions with the LCD. The LCD here will be 12t. So we're going to multiply every term by 12t over 1. So 12t over 1 times 1/3, 12t over 1 times 1/4, and 12t over 1 times 1 over t. canceling here. The t's cancel on the right side. The 4 goes into 12 3 times. The 3 goes into 12 4 times. What we're left with is 4t in the first term plus 3t in the second term equals 12. Collecting like terms, we have 7t equals 12. Dividing out the 7, t equals 12 sevenths. And if we just write this as a mixed number, that would be 1 and 5/7 hours. Now remember, we said that the answer should be between 1 and 2 hours. That is between 1 and 2 hours. It takes them 1 and 5/7 hours to complete the task together. Okay, we're going to look at a couple more examples of this, but here's a nice example to start. And you can visualize it, luckily, when you're thinking about a simple thing like a wall. Here's a second example of a work rate problem. It takes a small pump 20 hours longer to fill a swimming pool than it does a larger pump. Together they can fill a swimming pool in 24 hours. How long does it take each pump to fill the pool alone? So in this example, we know their together time. Together, it takes them 24 hours. Okay, what we don't know is how long it takes each pump to fill the pool alone. So when we don't know something, that's when we introduce a variable. Let's let x be the time it takes. Well, we've got to choose one of the pumps because we've got 2 pumps. The way to choose what x represents is to think about which of the pumps we know the least about. It says it takes the small pump 20 hours longer to fill the pool than the large pump, but it doesn't tell us anything about the larger pump. So let's let x be the time it takes the larger pump. That means that because the smaller pump takes 20 hours, the smaller pump is going to be x plus 20 because it's 20 hours longer. So we've got x for the larger pump, x plus 20 for the smaller pump, and 20 hours for the together time. Remember, our formula was 1 over a plus 1 over b equals 1 over t. What that represents, a and b are the individual times, so that would be 1 over x plus 1 over x plus 20, because I have the large pump and the small pump, equals 1 over t stands for together, the together time, 24. So to actually solve this equation, I need to clear fractions using the LCD. I've got 24x and x times x plus 20 rather. I'm going to multiply every term by that, and it should clear the fractions. So multiplying, I'm going to takes a little more time to write everything out. Here's the last fraction, 24x times x plus 20 over 1 times 1 over 24. We can now clear or cancel the common factors. The 24 cancels on the right side, x plus 20 cancels in the middle term, and the x cancels in this first term. Now going back through, multiplying things out. 1 times 24 times x plus 20. I'm going to distribute that at the same time. 24x plus 480. Feel free to use your calculator in application problem. Plus, in the second term, we have just 24x left, equals x times x plus 20 times 1 would be x squared plus 20x. All right, we can collect like terms. 48x plus 480 equals x squared plus 20x. We've got a quadratic equation because of the x squared. I want that x squared to remain positive, so I'm going to move these 2 terms over. So I'm going to have 0 equals x squared stays positive. When I subtract 48x from 20x, I get negative 28x, and then negative 480. We can factor that, and it may take you a little bit of time of factoring that negative 480, but take your time on it. And if you think through it, negative 40 and positive 12 will be the factors that work there. Double check it. 12 times negative 40 is negative 480. And then when you add positive 12x and negative 40x, you do get negative 28x. Now I did that rather quickly. If you want to, pause the video and double check that. But now we can set each factor equal to 0. And when we solve that, because I'm running out of room, I'm just going to go ahead and do it. X plus 12 equals 0 means x equals negative 12 when we isolate the x. And x minus 40 means x is equal to 40. Now, we can't have a negative for x because remember, x is a time. It's the time it takes a larger pump to get something done. And so it doesn't make sense to have a negative result. Remember, in applications, you can get extraneous solutions that are solutions to the equation, but they don't work in the application. So it looks like our one solution would be 40. Now that's for X. So remember, that's the larger pump. So 40 hours is what our units were in. And remember, the smaller pump takes 20 hours more. So 40 plus 20 would be 60 hours. If we wanted to do a little check of that, you could go ahead and say, well, is 1 over 40 plus 1 over 60 really equal to 1 over 24? You could throw that into the calculator and see that those two values end up being the same. I'll leave that for you to check, but it does work out. So in answering our overall problem, remember, always use in a word problem, talk about this in terms of what these answers mean in the real situation. So the larger pump takes 40 hours to fill the pool by itself. And the smaller pump takes 60 hours. So definitely go ahead and write your answer out in words.